everyone. This is a numerical problem, and this is related to the mud pump cycles. So the data we are given with is we have a drill string which is composed of 7,000 feet of 5-inch 9.5 pound per feet drill pipe and 500 feet of 8 inches OD by 2.75 inches ID drill collar, and the borehole size is 9.875 inches. So we need to find here the number of pump cycles required to circulate the mud from surface to the bit of the bottom hole, and then from bottom hole to the surface, and we are given with the pump factor, which you can see here. So let's break it down. So we have three type of holes here. First one is the drill pipe, drill string, uh, drill collar and borehole, and we are given with the data. And our objective is fairly simple. We need to find the number of mud pump in two cases, and the number of pump cycles in two cases. And here's the formula. So in case to find the number of pump cycles, we need total volume of mud and then the pump factor. So we already have the pump factor, which is given here. In both cases, we need to find the total volume of the mud. So let's start here. To calculate the volume of any pipe, we need its capacity, and here is a simple formula for the capacity. You can see here a diameter. This diameter is inside diameter. So in order to calculate the capacity of any tubular, we need to put value in here in inches. It must be ID inside diameter, and the result we will get in the barrels per feet. So here, our drill string case, we don't have the ID, so we cannot put the OD here. We need ID. But in case of drill collar, we are given with the ID, so no problem. And in case of borehole, again we have ID. So problem is just here. We need to find the ID of drill pipe. But luckily, we have this table. From this table, we can the input of this table is the OD, and there are two things we need to consider. One is OD and the second is the nominal weight, and luckily we are given with both of them. So in our case of drill pipe, if we see the table of 5 inches diameter and the nominal weight, which is 19.5 pound per feet, we can see the ID is here 4.276. So by using that formula of capacity, we can calculate the capacity. Here is we use the ID from the table. And in case of this above cases for drill pipe, the capacity of drill pipe is this, and we were given with the ID of the collar, so we put in here and find the capacity. So now we already know the formula for finding the total number of cycles is the total volume divided by the pump factor. So to find the total volume, we just have to multiply the capacity with the total length of the pipe. So in this case is representing the drill pipe. This case is representing the collar. 7,000 feet of drill pipe multiplied by its capacity plus 500 feet of collar multiplied by that's capacity. So finally we multiply them, sum them, and divide with the pump factor, and finally we can get the answer 719 cycles. So these are the cycles the pump have to work to put mud from surface to the bottom hole. So let's proceed and find similarly the annular capacity outside the drill pipe. So in this case, we have to consider all the mud which is in the annulus, not in the inside the pipe but outside the pipe and in the annulus. So in that case, to find the capacity, we have to consider uh, both OD and ID. So this is basically the ID of the borehole minus the OD of the pipe. So this will give us a capacity for the drill pipe section of the annulus. And the next thing is here we have the annular capacity of the drill collar. So our inside diameter of the borehole minus the OD of the collar, and we can get this. Similarly, by putting all the values, 7,000 feet of drill pipe multiplied by its annulus capacity plus 500 feet of drill pipe multiplied by its annulus capacity, we can find the total annulus volume here and divide it with the pump factor. We can calculate the number of cycles that mud pump has to work to displace all the mud from bottom of the bottom hole to the surface, and that's it. And okay, thank you.